My name is Richard Barnett. I'm the CMO for Supplyframe. I'm very excited to be at Electronica again this year. 2 years ago was my first time at Electronica, and it was a very different time. We were all dealing with just coming out of COVID, pandemic restrictions, travel restrictions, but we still had an amazing global Electronica presence. And Supplyframe had an amazing conversation about our new identity being part of Siemens and the Siemens family, but our history of 20 years of innovation in the electronics industry. So this year we've evolved. We have even more global presence. We have more customers meeting with us together here, and the market continues to be challenging. And I wanted to highlight a few things of what we're seeing across our global network of customers and engineers and procurement professionals that we're working with every day on insights around what's coming up for 2025 and the state of the electronics value chain. So we'll kind of talk about some overview of market dynamics and some of these key big themes that we've seen really unfold that are scaling right now. One is design for resilience, that concept of shifting left. Second is digital transformation overall around design to source. We just did an interesting market study, maturity study of automotive, aerospace and defense, high-tech global manufacturers. What is their relative self-reported maturity? And the answer is it's very low, but that means there's massive opportunity for improvement and for value creation. We will also talk about the hot topic that I think we're all tired talking about in some ways, which is AI. I won't try to define terms completely, but I will talk about what AI impacts that we're going to see unfold very quickly. Part of this is also in conjunction with Siemens EDA having a major announcement here at Electronica with their 2409 launch of a new user experience, new embedded AI and all the EDA applications that we see. But we can see this across not just the individual engineering experience, but across the digital threads that are transforming manufacturing, engineering, supply chain across multiple industries. And then we'll also look at sustainability. We'll highlight some of the opportunities and the gaps within the global electronics ecosystem to be ready to share and understand and measure the baseline measurements for product carbon footprint, and then incorporate that into global measurement of the impact of carbon. And then we'll look at our broader programming for the rest of the next 3 days. So when we look at market dynamics, we've obviously been through the unbelievable global pandemic, but it hasn't really stopped. There hasn't been any point of relief. We've seen cyber attacks. We've seen the war in Ukraine, geopolitical shortages, ripple effects impacting energy prices, extreme weather events, new geopolitical tests. We just had a major election in the United States. There's going to be an absolute review of tariff policies and the impact of that, not just across China, but with all global trading partners. We've seen the frequency and the impact of these external risk factors now accelerate. And the new normal is a increasingly dynamic environment. And those are external shocks. When we look at specific end markets, we've seen massive disruption. So we'll talk more specifically later today with Georg Steinberger about the German market and the impact of semiconductor sales and the impact and slowdown over the last 3 to 4 years. But really, this is playing out in a very complex way. It's really about key in-market shifts that are occurring, and then the digitization of almost every downstream industry. So the exposure to these risk events and their impacts has never been greater. We'll look at sustainability, the shift to globalization, to regionalization, and then digital solutions. So when we look at market dynamics, just to highlight a couple things that we look at every month, every week, and then we publish in reports called Commodity IQ Intelligence and across our entire network. And what we've seen as a high-level summary from 2023 August through to 2024 is high degree of volatility, but the overall health of demand and design has, been staying close to the 100% baseline. But just recently, I would say in the last 4 to 5 months, we've seen downward short-term indicators of both new design hardware intent and then near-term spot buys like e-commerce spot, indicating kind of tight market conditions. That has ramped down. But long-term demand for those end markets across every different passive sensors, logic diodes, and transistors is healthy. So we're in a market correction, and we've seen this market correction unfolding for the last year and a half. If anything, we knew that there was an inventory buildup of too much overbuying, sort of the bullwhip effect during the shortage, and it's taken too long for a lot of that inventory to be consumed and purchased down. We can see it in the book-to-bill ratios of every major broadline distributor that's here and represented, as well as our friends, those brokers, that had a very, very hot year. We're living on probably the best market dynamic that they could possibly imagine 2 years ago. Well, a lot of that has ramped down. We're not seeing that kind of spot buy behavior, but what we are seeing is a strategic reallocation of excess inventory from key manufacturers and others trying to rebalance because they have too much inventory of the wrong items, and we're going to see increase in constraints. In analog ICs in particular, this is an area that we also pay attention to. We're seeing an interesting shift in the near term where overall expansion capacity events in analog versus the latest nanometer diode, latest nanometer semiconductor, say 28 nanometers and above. That's where all the major new capital investments that are going to come online in the next 3 to 5 years. A lot of this based on the CHIPS Act, the United States, for example, and similar legislation in the EU, China, and Korea. But in analog and in areas that really impact automotive, for example, we're seeing a near-term slowdown in consumption of inventory, which is an indicator of near-term constraints that we're going to see play out in the next 6 to 7 months. And the automotive industry in particular is on its way to try to redesign out this kind of risk area of over-reliance on analog, but it's taking a long time. What we're seeing is this is taking 3 to 5 year new program cycles with new EV platforms to be redesigned in. And this first wave, I would say, of every major global OEM, where they've organized teams that are cross-functional from design, sourcing, supply chain to look at risk in the overall design of these new platforms, is just beginning to get started. So we're going to see improvement, but we're not going to see the impact and the reduced reliance on risky upstream, nodes in the supply chain, including analog, really stabilize for about another 2 to 3 years. So we're keeping our eye on multiple different commodity groups as well as in-market demand shifts that are driving potential constrained and mixed behavior. Obviously, AI, data center, high bandwidth memory has been the areas that you have severe, indicators of market constraints. You could argue there's some overbuying, but really this is going into new data center demand, and we can see already the constraints emerging. So it's going to be spotty constraints with overall stabilization of inventory. Now, when we look across the supply frame intelligence across our whole network, we're kind of trying to look at both a balanced view of what new design and intent is happening. So that's a future indicator that could be out a couple years of net new hardware cycles, as well as very near-term views of current lead time, current inventory, current pricing, of over 600 million components actively. And we continue to expand that intelligence all the time because we believe that we're just still scratching the surface around pulling in every other relevant source of intelligence and then understanding new relationships between them. So one big area of focus for that is in-market demand changes. Another area of that is correlating other factors that are driving impacts into the global electronics supply chain in terms of raw material inputs. We spent a lot of time in battery, for example, in the battery ecosystem, which has been really interesting to see that evolve. But with sustainability and the expansion of product carbon footprint, we also believe that's another dimension. So we're increasingly seeing a shift to trying to make design decisions with outside-in market intelligence that are taking into consideration not just what is best for quality, best for performance goals for that design, but what's the real-time market conditions from a global supply chain perspective? What's a predictive view so that you don't design in the wrong part for, not just for obsolescence and lead time, but for potential market shortages? And increasingly, what is the overall sustainability impact from a product carbon footprint perspective? We're not seeing real trade-off decisions being made because basically the equivalent of a component, we'll talk about this, that's within a certain packaging is almost equivalent, right? It's their equivalent MPNs from their product carbon footprint at this point. But the source of manufacturing is increasingly important around the full impact of where you're sourcing and where you're doing final assembly. And those trade-off decisions will increasingly become important in terms of the design for resilience shift left move that's happening in the market. So if we look across many organizations, many companies, whether they're, could be a $20 million specialized manufacturing services company in Germany, or it could be a global $60 billion aerospace and defense or high-tech OEM. The pattern is almost the same across every organization, across industry, across size, which is that we are characterized by silos between engineering, procurement, and supply management. We've seen organizations that have the best world-class digital thread, digital platforms for engineering across multi-domain engineering, across mechanical, electronics, software design. Oftentimes they're taking a journey in partnership with Siemens. But as soon as you look at the decisions and the connected processes that occur around new program management, costing, procurement, supply management, it's characterized by Excel spreadsheets, quotes from suppliers being shared back, ad hoc. We need to work on designing in for resilience because 80% of the life cycle cost, risk, and sustainability impact is locked in the design phase for almost every new product that's being designed, again, regardless of the end market. So if we don't make those design changes when we have the degrees of flexibility in design and engineering to evaluate them, the cost of change is much, much higher. It's harder to requalify a supplier, particularly in regulated industries like medical devices, for example, or aerospace and defense. Cost of change can be millions of dollars for one supplier for one component, and that component could only cost 3 cents. It's true. So what we're seeing is this broad shift to think about extending our digital threads, our digital transformation efforts, and then connect basically through the same intelligence so that design engineers are seeing the same information that's updated from both the market and from within every decision that's happening downstream in their organization. So every time I source and have a competitive bid from different suppliers, every time I'm seeing supply demand impacts where I can see new risk drivers for new end products, I can bring that in, I can scenario plan that, I can understand what optionality I have here in design, and then share a closed loop decision making with outside-in intelligence is constantly on, that's infusing and providing empowerment for design engineers, program management, procurement, and supply management teams. We did a design to source market intelligence study earlier this year, and it was quite interesting because we looked at automotive, aerospace and defense, and high tech, and we said self-report what your level of maturity is in the areas that we call design to source. So it's, what is your degree of collaboration between engineering and procurement teams? How focused, what's your kind of systems of record or engagement that you're using, digital systems that you're using to communicate and manage your collaboration with your key suppliers? What we learned was somewhat surprising. The average score, the best-in-class score of 1 out of 5 was 2 for aerospace and defense, leading the way. Automotive at 1.1. High-tech was 1.3 out of 5. Self-reported. 80% said that they want to move to a highly collaborative digital process, but only 16% would describe their current level of collaboration between their engineering, supply chain, and procurement teams as highly integrated, highly connected. 75% self-reported that they're primarily using Excel spreadsheets and email quoting for early quote and sourcing analysis, and they're not sharing or storing that information over time. So they're not learning in the market or sharing it across their silos. Again, this is all based on silo organizational design at root cause and lack of incentives that align to the full health and life cycle of a new product. So there's many opportunities for organizations to get started. There's a lot of low-hanging fruit to just digitize certain processes, make them more efficient, bring some outside-in intelligence, and we'll walk through some of the stories of working with our customers around where they've seen incredible impacts and value around efficiency, time saving, cycle time reduction, and actual massive cost reduction in a very, very short period of time. But it really involves having a life cycle view of the product from concept all the way through delivery, and really working on how do we reduce time to market, reduce costs in a sustainable way, and actually reduce risk. And part of these questions is digitizing your process. Part of it is bringing the right intelligence to say, what is our best view of cost? What is our risk factors that we need to measure? And then how do we consistently measure and improve on that over time? So a lot of the work that we're seeing right now in the market is early. We're excited about it. We think we're just getting started. It can be massively transformational for both companies and for ecosystems. So one of the other things that we'll hear about is David Youngblood from Avnet. We'll hear, Jabil, our partners from an EMS perspective, kicked off a a new way of thinking about how do we collaborate across the ecosystem? How do we get away from the concept of a quote, right? Because why do we need to throw Excel spreadsheets with thousands of lines for MPN costing updates that then don't get stored or used in a consistent way? There's too much noise in the system. How do we isolate what is the 20% of true demand of new product collaboration and the decision-making that needs to occur, and then automate the 80% that's just a digital, always-on available flow of information that's aligned to long-term agreements to in specific customer markets? We can accelerate the digital transformation in these areas. So I told you I would talk about AI. So show of hands, who's excited about AI? Okay, who believes we don't have a single definition of AI? I feel like every time this comes up, we got to define terms, then it gets really complicated really quickly, right? Because I was at this supply chain event earlier this year, and that's when I felt like we reached peak AI noise. There was like, well, there's Gen AI, and then there's old AI. I was like, no, there's no Gen AI, old AI. It's all AI. I mean, it's all math, basically, right? I mean, when you talk about applied AI in engineering or in supply chain, there's AI methods like machine learning, for example, that we've been using for a very long time. We've been using simulation technology, genetic algorithms, neural networks in applied and very specific models for a very long time. Gen AI and the use of large language models has piqued everyone's consumer imagination. As a personal story, I just got married a couple weeks ago. My wife is Hungarian, Romanian, and half of her family didn't speak English. So we had ChatGPT going on the phones at 3 a.m, and everyone was able to communicate going back and forth from Hungarian to English. It's amazing, right? We're all experiencing these impacts of AI on a personal level. But when we look at EDA, we look at engineering, and we look at some of the applied AI methods that we're doing across our whole network, in some ways it's a combination story of some things that are very mature, embedded, like machine learning, and some that are very new. So we're going to see a lot more focus around guiding engineers to reuse or share their best practice patterns in board layout, block design, and then in selection of key components, new factors to assess and understand predictive insights around risk, for example, or use in comparison, and recommended alternatives, for example, with advanced search. All of those are basically streamlining the process, making it more efficient, but more importantly, they're doing something also that's beyond just a co-pilot experience. They're capturing the knowledge of experts in their engineering teams and being able to reuse and share that across teams so that newer engineers that are coming into that design group or in that end application are learning from what's worked best and getting recommendations slowly around what can be reused or should be considered in the next gen design. We also will see a lot of work that's embedded in the insights and the data sets around broad scale engineering. So in IC design, for example, for semiconductor, you have much larger data sets that are being modeled and then used. So whenever you have large data sets, you always have more opportunities to potentially do a hybrid LLM or train a new model. If the data sets are really narrow, you don't really think about those as your leverage points. But if you think about learning across a community or at scale, so Siemens EDA will be talking, and Magenta here, raise your hand, Magenta is going to be interviewing and talking through their 2409 highlights and what they're doing at scale. And some of the implications of that are, how do you learn across the community of all users in EDA tools or in engineering tools over time? We're effectively beginning to do that as well with our SaaS solutions and our search experience that brings together more of a natural language process for recommending and getting actions that are automated from an agent model inside of those digital workflows, so that you can basically not be an expert in maybe how to trigger a sourcing event, or you might want to get recommendations on the best alternative parts based on certain parametric attributes without getting lost in too much information, too much one-by-one technical review. It can massively streamline decision-making. And we bring a lot of outside-in intelligence that uses AI and predictive models, so we can bring real-time market intelligence or predictions around what's going to happen in the next 3 months or 6 months at a commodity market level, at a product class level, and inform people to anticipate the future. And those are all different applied AI methods in different aspects of these workflows. But the main point is, I know we will actually have arrived to a different level of digital maturity when we're actually not using the term AI at all. It's just math done in a nice way that gives new experiences for decision-making, for discovery, for collaboration. And we're talking about the business outcomes of what we're driving through the digital innovations that we're making. And of course, AI is going to be a part of it. But every time we see an AI slide, every time we walk down one of these booths that everyone's talking about, I don't know what that is over there, by the way, but this is the world in which we're living in which we're trying to conceptualize the future, but this is not the way. When things get boring is when we actually will arrive to the right level of maturity. So keep that in mind. And finally, when we look at sustainability, early stage trade-off decision-making, incredibly important. If you design for sustainability, for recyclability, for design reuse, for example, that from concept to product development is really where you're going to have the biggest impact on the life cycle, product carbon footprint, and sustainability impact of a product or of a product and solution that's being brought to the market, because the costs of change are incredibly high downstream. One of the challenges in the electronics ecosystem is that while we have benefited from standardization, you can have manufacturing part numbers that are equivalent. You can have parametric-based decision-making where you're evaluating close or equivalent alternatives. And you can do that at scale. Distributors, full visibility in the market, multiple different, potential suppliers, solution providers, maybe qualifying things for certain end markets. The standardization of those part attributes has been amazing. If you look at mechanical, for example, standard parts, you don't have the level of standardization. There's no MPN. Everything is attribute-based, for example. But when it comes to carbon product footprint, standardization, self-publishing, any of this information, we are at a standstill as an ecosystem. The most advanced work of self-publishing is happening with advanced semiconductor ICs companies, and they're giving that information only to their largest customers when requested. We literally have millions of parts that have no standard calculation for their product carbon footprint. So Supplyframe decided to take a leap forward and build a baseline starting point of over 380 million parts that have product carbon footprint. But we believe that's just scratching the surface because those are naked parts. What's far more important is to connect the part information with the actual logistics flow. Where is it manufactured? How is it final assembled? What are the energy impacts and what are the transportation cost impacts on its entire life cycle from early design through, first procurement all the way through the product manufacturing process. But it's a standard way of building a starting point. And what we hope is, just like we came together over 10 to 50 years and digitized all of our product catalogs, we will now come together with greater standardization for more self-publishing and validation with recommendations, perhaps, of both product carbon footprint and then the full sustainability stack. Right now in many industries, like in automotive, they're requiring Scope 3 emissions, they're requiring multi-tier traceability and reporting from suppliers. But they're doing that on an aggregate company, enterprise, or manufacturing site location basis. What we are really behind on is actually decomposing that footprint from a manufacturing perspective into discrete parts, and then the bottom-up view of a bill of material to understand its bottom-up impact on a product carbon footprint perspective. Once we have that, then we can start optimizing. We can start optimizing at the product bill of material level, and we can start optimizing for supplier selection, because the equivalent MPN is sourced from a lower cost impact from manufacturing or from logistics costs, now may be preferred, and we might be willing to invest slightly more for having a lower carbon footprint if we can measure it in a standardized way at the bill of material level. But if you can't measure it, you can't optimize it. And this is the problem, is that we're all flying blind right now in this market. We're expecting this to accelerate in terms of adoption and standardization, but we're not there yet. This is me on LinkedIn. Feel free to connect with me if you like. Happy to meet with you here as well. And then just a shout out for the next 3 days, I'm very excited about the programming. We have a great conversation with SC Special, their digital transformation. APAC COSIS, great conversation around how they're proactively managing risk and achieving very strategic goals around a difficult market dynamic in Germany. On tomorrow, we have challenges and opportunities for German distribution. That's a conversation I'm having with Georg Steinberger. We're going through the digital thread of the resilient component from our friends from Siemens EDA. And then we have a great conversation with Dave Youngblood, who's a digital transformation leader who recently joined Avnet. We'll be sharing his perspectives around being a digital transformation leader and the opportunity and the focus that Avnet has on the market and the ecosystem. And then finally, we'll have the green digital twin conversation with Florian Schmidt, and then how digital threads are driving transformation roadmaps. So these are great conversations. Please come back by. We will record these as well. We're happy to share them afterwards, but let us know if you have any questions. Thank you very much, and have an amazing Electronica.